Face, hang on. Cecilia, can you hear me?
Yes.
All right, cool. No echo or anything weird like that?
No, you're fine.
All right, cool. Awesome. All right, guys. So all back together as a class. We are going to, all we're going to do while you're kind of waiting on me to get adjusted is you're going to keep your paper portrait and you're going to draw an X and Y axis taking up the whole entire front page. So draw a long X and Y axis filling up the whole page. And then we're so not done with parabolas. We are going to graph parabolas as conic sections. Yes. The Y is going to be up and down. Let's keep it portrait. All right. So we're taking things slow today, y'all. And the reason why we're slowing things down is because of two reasons, really. It's the end of the grading period. You guys have a 3-day weekend, which means whatever I really teach you, some of you guys might not remember on Monday, and this is some pretty important stuff. Also, I wanted to take an opportunity, I'm not gonna lie, I totally wanted to show a video in class. So I had an opportunity to show a little cheesy YouTube video, so I did that. And then one more thing is you guys need to practice making some good, clean looking graphs. So that's what we're practicing today. Okay, so here's how we're going to format this. On the upper right-hand side, we're going to write something in vertex form. Please let me know at any time if you can't see my screen. And then we're going to convert this to conic standard form in a few minutes. So I'm just going to go ahead and have my template here. And what we are going to do is we are going to write this equation. And guys, I'm using erasable pens. Even though I've been doing this all day, I still make mistakes. So if you got erasable pens, cool. If you don't have erasable pens, that's pretty risky. Here's what we're graphing. We're going to graph y equals, and that is going to be a 1/8 x plus 3 squared minus 2. But we're going to graph this like a little piece at a time. The first thing we're going to do is we're going to plot the vertex. Y'all, where is the vertex? Awesome. So we know the vertex is at -3, -2. So let's go ahead and plot that vertex. All right, cool. So from here, would that graph open up or down? And how do you know that? Positive A. Speaking of the A, is that a stretch or a shrink? It's a vertical stretch, y'all. That's a vertical stretch. When A is less than 1, it's a vertical stretch, which means this is going to be a pretty wide parabola. What else was I going to ask you? Oh, here's what we're going to do. We're going to remember the patterns. So we're going to take X, we're going to square X, we're going to multiply it by the A value, and remember that tells us to go up or down. So what is the A value though? 1/8. And not only is it 1/8, we have to make sure we have lattice points. Do y'all remember what lattice points are? Who remembers what lattice points are?
They're points in which the x and y values are both integers.
Yeah. Yeah, just whole numbers and integers. That's right. That's what somebody said here. Yes. So no floating around on the white space of the graph paper, y'all. That's our game. That's what we need. So if I tried to put a 1 here, that would be 1 times an 8th. That's not going to work for me because 1 times an 8th is a fraction. We don't want that. So what number can I put in for x to give me a whole movement for y? Awesome, 4. Let's do 4. So if I put 4 here, That's going to be 4 places to the right and to the left of the vertex. And then remember 4 squared is 16 and our A value was 1/8. So there we go. Let's go ahead and go back to that vertex, go 4 places to the right, go up 2, 4 places to the left, and go down 2. Sorry, 4 places to the left and go up 2. Okay, cool. We need another number that would give us a whole number for a y movement. What else can we do? 8? Let's try 8. So 8 is going to be squared, so it's going to be a 64. And then a 64 times an 8th is going to be, yeah, so 8 places to the right and to the left, and 8 places up. Okay, guys, the best that you can, sketch the parabola. Try to make your curve as smooth as you can. Mine certainly isn't going to be perfect, but do try to put some effort into it. So up to until like, I don't know, maybe 2 or 3 minutes from now, the only parabolas that we've been graphing are vertical. This is a vertical parabola. I know it's a vertical parabola because it opens up. Vertical parabolas also open down. So we've got ourselves a nice, perfect little parabola here, pretty wide, has a vertical stretch by a factor of 1/8. Speaking of 1/8, there is a very important measure hiding out in A that you didn't know about that you're about to know about. The very important measure hiding out in A is that the reciprocal of the A value is the official focal width of the parabola. What's the A value again? The reciprocal. So what's the reciprocal of 1/8? So you need to find on this parabola where the width is exactly 8 units across on your graph paper. And when you find that, you're going to put a dotted line from one edge of the parabola all the way to the other edge. Has to be 8 units long. Yes, it just happened to be sitting right on the x-axis. It wasn't planned like that. Okay, y'all, let's put a dotted, not a dashed. Let's save dashes for later. Let's dot out this line because that is very important. And why are we dotting out this line again? This is the focal width of the parabola. And how long is it? 8 units. And how did I know that it was 8 units? Because it's always the reciprocal of A. So the focal width is pretty important, but the midpoint of the focal width is the driver of the whole parabola. So let's find where the midpoint is. Your midpoint for that focal width should be directly above your vertex. And this is the focal width. This guy in the middle is called the focus. So let's talk about the focus. The focus is directly above what? The vertex. Also, the focus is always on the inside of the curve. This focus is never somewhere else. It's always directly above, directly below, directly to the right, or directly to the left. Wherever the shape of the curve is, the focus is inside that. The focus also goes through the line that I didn't graph that you graphed a lot in Algebra 1. What line is usually graphed when you graph parabolas? Axis of symmetry. Let's go ahead and graph the axis of symmetry, y'all. What is the equation for the axis of symmetry? X equals -3. So let's use a dashed line and let's plot the axis of symmetry. So we knew that the axis of symmetry always went through the vertex. Now you know the axis of symmetry always goes through the focus. How far away is the focus from the vertex? That's right, 2 squares, 2 units. Go 2 units on the outside of the curve, and there's a line hiding out here too. Let me show you. So let's just talk about what I just said. 2 units up, 2 places away is the focus from the vertex. 2 places in the other direction is called the directrix. And look how I graph this. Your directrix is either a horizontal or a vertical line. Your directrix will never cross the parabola at any point, and it is always parallel to that axis of, I'm not parallel, perpendicular to that axis of symmetry that you already knew about. So now that we've talked about these additional pieces, here's what they mean. This measurement right here, and I wish I had a highlighter, I do. This measurement drives the whole entire equation when it's in conic standard form. That measurement is called P, and P is the distance from the focus to the directrix. I'm sorry, from the focus to the vertex, and it is also the same exact distance from the vertex to the directrix. There's P's always in the focal width. What is the distance of this P value again, guys? How many 2's are in the focal width? 2 times what made 8? So your official width of the parabola, your focal width, is always 4 P's. Uh-oh, that's why I use erasable pens. That P value was hiding out in vertex form the whole time. Remember, your vertex form is the reciprocal of the focal width. So your vertex form, your stretch right here, your A value, is 1 over 4P. We're going to talk about that in a second. Don't worry about writing that down right now. But speaking of vertex form, we're going to convert this to conic standard form. In order to convert this to conic standard form, y'all, it's pretty easy. All we have to do is just have this by itself. That's all you got to do on that equation. So if we just need that squared term by itself, how would we do that? What would you start doing to that equation to just get push everything on the other side? What would you start with? Yes, add 2 to both sides, then what? Multiply by the reciprocal of A. And what is the reciprocal of A? The focal width. So your conic standard form is going to look like this. Remember, it's the reciprocal of A, which is 8, times y plus 2. You guys told me to move the 2 to the other side. And that is going to equal x plus 3 squared. Don't feel like you have to take additional notes. If you're fuzzy, this is all brand new. You're exactly where you need to be. Okay, so all we did is we manipulated the same exact equation to look a different way. It would still graph the same thing on a calculator. What you need to walk away with is P is always found by A. P is always found by A. A is always 1 over 4P. And P is everywhere on this parabola. P is the distance from the vertex to the focus. P is the distance from the vertex to this new line we know called the directrix. P is always 4 times, and that will give you the focal width. That's never going to change. Even if the parabola is sideways, which is what we're going to graph now. So let's turn our page over. Let's draw an X and Y axis again. We are going to draw a horizontal parabola.